People say willow bark is natural aspirin. It is a useful phrase and a misleading one. If you chew a strip of bark from the right willow, you will taste bitterness long before you find anything we would recognize as a modern tablet. There is no neat white pill hiding inside the tree. There is bark, fiber, moisture, tannins, and a family of salicylate-related compounds that human beings had to notice, test, isolate, alter, and finally manufacture. That longer story is better than the shortcut. It begins with a tree that likes wet ground and carries its chemistry in the bark. It passes through an Oxfordshire clergyman who powdered that bark for fever, 19th century chemists who chased bitterness into crystals and acids, and drug makers who tried to keep the benefits while reducing the misery in the stomach. Along the way, old observation became laboratory procedure, and a plant remedy became a different thing entirely. So willow bark is not aspirin, but without willow bark, the history of aspirin would look very different. To understand why, we have to separate the living tree, the dried bark, the compound called salicin, the acid called salicylic acid, and the synthetic drug called acetylsalicylic acid. They are related. They are not identical. And when we blur them together, we lose the real achievement. Not the discovery of a miracle already waiting in nature, but the slow human work of turning a bitter clue into modern medicine. White willow belongs to the genus Salix ***. Q records ***Salix alba as native across much of Europe, Western Asia and North Africa. It is the kind of tree that suits river margins, damp meadows and other wet ground, where fast growth matters more than hard, durable timber. That setting matters because people notice useful plants where they live with them. A willow is easy to cut, easy to coppice and easy to revisit. Its rods can bend. Its bark is bitter. Its leaves and twigs are unmistakably part of the same living chemistry, but bark became especially important in herbal practice because bark dries, stores and travels better than fresh foliage. The bitterness is not a trivial detail. For premodern medicine, taste was evidence. Bitter plants were noticed, compared and remembered. Long before modern pharmacology could describe a salicylate, bitterness gave practitioners one crude clue that a plant might do something active inside the body. That did not mean everyone understood the same thing or used the same preparation. A remedy made from fresh bark, dried bark, tea, powder or tincture was never exactly the same medicine. One willow species was not another. Dose was uncertain. Timing was uncertain. Preparation was uncertain. The honest beginning is not that the old world had aspirin in botanical form. It is that people kept returning to a bitter tree because experience suggested it was worth returning to. The best documented turning point in English is not a lost ancient recipe. It is a printed report from 1763. That year, the Reverend Edward Stone wrote to the Royal Society about the bark of the willow in the cure of agues. Ague was not a precise modern diagnosis. It was a term used for recurring fevers and chills, often in places where malaria could also be involved. Stone's account belongs to a world before microbes, before mosquitoes were understood as vectors, and before controlled trials in the modern sense. Even so, the report matters because it is empirical. Stone described noticing the bark's bitterness, comparing it to Peruvian bark, drying it, powdering it and trying it over time in patients with feverish complaints. He was not proving a mechanism. He was testing a practical resemblance. One bitter bark had a reputation, perhaps another bitter bark might help as well. That is not modern evidence, but it is recognizable as a step toward it. A plant was chosen, prepared, given, watched and reported in public. The willow entered a written scientific culture. Many later histories push farther back, to ancient Egypt, Greece or other long traditions of plant medicine. Some of those links may be real, but they are often repeated too confidently and too neatly. For this story, the safe ground is stone. By 1763, we can watch willow bark move from remembered remedy into an institution that printed observations for other learned readers. A bark remedy is one thing, a purified compound is another. In the late 1820s, chemists succeeded in isolating salicin from willow. That was a major change in what counted as knowledge. A healer can say a bark helps. A chemist wants to know what in the bark might be responsible, how much there is, how it can be separated, and whether a more concentrated preparation will behave more predictably than a handful of dried powder. This is where the familiar myth begins to harden into something misleading. Once salicin enters the story, people often speak as though the important medicine was finally found inside the tree in finished form. But salicin was not the end of the chain. It was an intermediate victory. Chemists kept going. In 1838, Raphael Perea converted salicin into salicylic acid. That step matters because it shifted the story further away from plant handling and further toward transformation. The point was no longer simply to gather a useful tree. The point was to extract, identify, convert, and compare. Every step also changed what patients actually received. Bark is a mixture. Salicin is a more specific substance. Salicylic acid is another specific substance again, with different potency and different problems. Once people talk loosely about Willow, they risk hiding the fact that 19th century chemistry was steadily breaking the old remedy apart and rebuilding it on new terms. If salicylic acid worked, why not stop there? Because effective and tolerable are not the same thing. By the 19th century, salicylic acid and related salicylates were known as useful medicines, especially in the treatment of pain, fever, and rheumatic conditions. They were also unpleasant. Historical accounts and later medical histories repeatedly return to the same problem: bitter taste, stomach irritation, nausea, and difficulty tolerating the doses needed for treatment. That is where chemistry stopped being a scholarly exercise and became a practical necessity. A medicine can be pharmacologically active and still be a bad product. If it burns the stomach, tastes dreadful, and makes patients abandon treatment, then the work is not done. In 1853, Charles Frederick Gerhardt produced an impure acetylated form of salicylic acid. He was trying to improve the drug, but he did not turn it into a stable medical product. Later, at Bayer in the 1890s, chemists including Felix Hoffmann worked on the same general problem with better tools and industrial ambitions behind them. Human trials reported in 1899 supported the new compound as superior to older salicylates, and on 6 March 1899, Bayer registered the product under the name Aspirin. That date is often told as a moment of invention. It is better understood as a moment of consolidation. The tree did not suddenly become a tablet. A large chemical industry had taken a long trail of observation and turned one branch of it into a standardized commercial drug. This is the sentence most worth getting right. Willow bark is not aspirin. Aspirin is acetylsalicylic acid. Willow bark contains salicylate-related compounds, especially salicyl glycosides that yield salicin and eventually salicylic acid metabolites in the body. Those relationships are real, but they are not equivalents. The European Medicines Agency states the pathway plainly. Salicyl glycosides of willow bark form salicin after hydrolysis. Salicin is degraded into salignin and glucose. Salignin is then oxidized in blood and liver to salicylic acid. That is already a more complicated journey than the wellness slogan allows. EMA also notes something else that is easy to miss. Constituents other than salicin may contribute to the overall analgesic effects of willow bark. In other words, even when regulators discuss willow in pharmacological language, they are not reducing the bark to a single magic ingredient. Modern aspirin is simpler in one sense and more artificial in another. It arrives as a deliberately manufactured molecule with a known dose. Once swallowed, it can be absorbed and later converted back towards salicylic acid, but its practical identity as a medicine comes from standardization. That is what the tree never provided on its own. So when people call willow bark natural aspirin, they collapse a mixed botanical material, a metabolic pathway, and an industrial drug into one phrase. It sounds tidy. History was not tidy. The modern evidence is neither folklore dressed up as certainty, nor a total dismissal. EMA distinguishes between different kinds of willow bark preparations. A quantified dry extract is recognized for short-term treatment of low back pain under well-established use. Separately, traditional willow bark preparations are listed for minor articular pain, fever associated with common cold and headache. The wording matters. Traditional use does not mean modern trials have proved every claim strongly. It means the use is plausible, long-standing and regulated within a weaker evidential category. The U.S. National Center for Complementary and Integrative Health puts it even more bluntly. Willow bark has been used for centuries, but only a few small clinical trials support willow bark extracts in chronic low back pain and osteoarthritis. NCCIH also notes that a 2019 review, written to guide decisions about chronic musculoskeletal pain, recommended against using willow bark extract in that setting. That sounds contradictory until we remember what kind of question is being asked. Could a standardized willow bark extract show some short-term benefit in some pain conditions? Possibly yes. Is willow bark therefore a broadly endorsed answer to chronic pain? Is chewing bark from a random tree equivalent to taking a regulated extract? Also no. This is the pattern we should expect from many old remedies. When modern medicine tests them, the result is usually narrower than popular memory. Some indications survive in reduced form. Some remain unproven. Some turn out to depend on preparation, dose and patient selection so much that the folk summary stops being useful. Natural does not mean simple, and it does not mean safe for everyone. EMA lists important contraindications and warnings for willow bark products. Salicylate sensitivity, aspirin-sensitive asthma, active peptic ulcer disease, coagulation disorders, severe liver or kidney dysfunction, and use in children and adolescents because of the risk associated with Ray's syndrome. Use is not recommended in pregnancy and lactation, and willow bark may increase the effects of anticoagulants. NCCIH adds the same broad message from a different angle. Reported adverse effects are often gastrointestinal. Some people are sensitive or allergic to aspirin-like compounds. Bleeding risk may increase in vulnerable individuals. Children, pregnant or nursing people, and those with known aspirin sensitivity should avoid it. All of that is worth saying because willow bark attracts a particular kind of romance. It seems older, greener and less processed than a tablet. Sometimes that encourages the idea that it is gentler by default. But history ran in the opposite direction. Chemists kept modifying salicylate medicines precisely because older forms could be harsh, variable and difficult to tolerate. The safer lesson is not that nature had it right first time. It is that observation found something interesting, and later chemistry spent more than a century trying to make that something more usable. The white willow did not hand humanity a finished drug, it offered a clue. A bitter bark by wet ground became part of a chain that passed through trial, memory, print, purification, synthesis, side effects, commercial standardization and regulation. At each stage, people lost something and gained something. They lost the simplicity of the story. They gained precision. That is why the real history is better than the slogan. If we say willow bark is aspirin, we erase the work of Stone, of the chemists who isolated salicin and pushed it onward, of the physicians who discovered tolerability problems, and of the industrial chemists who remade the molecule into a standard drug. We also erase the limits that modern regulators and reviewers still place around willow bark itself. The tree remains what it always was, a living organism with useful chemistry in its tissues. The medicine that came later is a human arrangement built on that chemistry, not a perfect gift lifted whole from the bark. Willow kept the beginning of the story. Chemistry wrote the middle. Regulation now argues over the edge cases. And the distance between bark and tablet is exactly where the history lives. Before it was ours, it already had a story.